Hello, today we are going to venture into a new topic from our triangles unit. Today we are going to begin talking about two-column proofs. If you ask one of your parents or someone older like myself, one of the things that they may tell you they really weren't too fond of in high school geometry was proofs. They had to do them, at least I did, for weeks on end, and they weren't really something I enjoyed. I didn't really learn to like them until probably when I was in college. So we're going to do them with triangles in hopes of making this process as we learn about what they are and how to use them a little less daunting. We're going to use the same triangle postulates that we have been talking about, and we're going to write a two-column proof that shows what our thinking is. Let me just start by going over what exactly is a proof. Well, a proof, in its definition according to math.com, is a way to assert that you know a mathematical concept to be true. In other words, you're showing why something is true. It has to be a logical argument that is going to establish the truth of a statement. Building of a proof requires critical thinking, logical reasoning, and disciplined organization. Writing a proof is like playing an intellectual game. You have to decide upon which pieces to use for this puzzle and then assemble them to form a picture of the situation. Basically, it's telling whoever is reading the proof why you believe what you believe. If you think about like in debate classes and speech classes, you have to give an argument for something, or maybe even already in your English classes, you've had to write maybe a persuasive essay, and you have to say why you believe what you believe. This is the same idea, only it's in math. So you're having to say why this math statement is true. Why are these triangles congruent? And you lead the person who's reading the proof through your train of thought. There are three basic types of geometric proofs: the two-column proof, the paragraph proof, and the flow proof. The two-column proof is the one we're going to focus on because it is the easiest one to organize. A paragraph proof uses literally paragraphs, so all words, so it's a little harder to organize. And a flow proof uses a whole bunch of boxes with arrows that connect them. And that's a little hard to, number one, do in this type of situation where we're all working on devices of some sort. And also, it's just a little bit harder to organize your thoughts. So we're going to focus on the two-column proof because it's just the easiest way to go through an organization. So here's what a two-column proof looks like. As its name implies, it has two columns. One of the columns, the one on the left, will be titled statements, and the one on the right will be titled reasons. In the statements column, I didn't write anything underneath there, but in that you would list what it is that's true, like angle A is congruent to angle D. That would be a statement. Or triangle ABC is congruent to triangle DEF, and you're going to use that as a statement. And then in the right column, the reasons column, you're going to give the reason why your statement is true. There are basically four things that you can write in the reasons. It can be something that is given to you in the drawing. It can be a definition, like the definition of midpoint, the definition of perpendicular, the definition of bisect, something like that. You can use a theorem or a postulate. So anything that has been told to you as your geometry classes, in this context, the postulates are going to be those triangle congruence postulates: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Those are all a reason that you could list something. And then the last one would be a property, like the reflexive property or the transitive property or something like that. When you are writing your two-column proof, you need to keep a few things in mind. Number one, you number each step so we can tell your process train of thought. Number two, you always start with the given piece of information. Number three, draw a picture, which in this case, I'm going to give you pictures, but you might have to mark on them given information. You must have a reason for every single statement, and the reasons can be definitions, postulates, properties, or previously proven theorems. Givens are only used as a reason if the information in the statement column was literally given to you in the problem. That's the only time you're going to write given. And then the last one is you can use symbols or abbreviations for words within proof. So you can use the congruent symbol to replace congruent. You can use the angle symbol to replace angle. You can use the triangle symbol to replace triangle. But it has to be something that's commonly used across the board. So what would it look like? Okay, so you would be given a picture like this one over here, and you'd have a given statement and a prove statement. Now I added this box around there, so it wouldn't be there yet. It would just have that written in black, and then this prove statement in black, and then we would have the information down here. So what you do is you always start by restating the given information. So your proofs over here, they're kind of like a paragraph, sort of, in that it's going to have an intro, a body, and a conclusion, just like you learned about your paragraphs in your English classes. So the introduction is always the given. So whatever information they give you, or maybe is already marked down here, you would list over here as given. So the fact that segment AC is congruent to segment BD, that's the first thing that's written down. So we write it as a statement, and the reason is the fact that it was given to us. And then angle ACD is congruent to angle BDC. We'd write that down because that's a given. And then the next thing that you would look for is the body. Now, the body is things that are not given to us, but things we know to be true based on something. For example, we know CD or DC is congruent to itself by the reflexive property. We talked about that the other day. So we could say, all right, DC is congruent to DC. Why do we know that to be true? Because of the reflexive property. At that point, we know these two triangles, the top left and bottom right, to be congruent because we have side, angle, side, and side, angle, side. So we can say, oh, hey, triangle ACD, top left, is congruent to triangle BDC, bottom right, because of the side, angle, side postulate. And then we're going to have our conclusion as the very last thing. The conclusion should always be exactly what was written in the prove statement. So angle A is congruent to angle B. We want to identically put that as our last statement. And then we'll have a reason over here. Now it can't be prove like the given was up here. These are the only two that are not going to be a property or a postulate or something. And this one is because corresponding parts of congruent triangles are congruent, and we'll get a little bit more into CP/CTC tomorrow. Right now, I'm trying to make sure you understand the setup of your proof. These are more like the ones they're going to look at like today on your assignment. So you will have a given over here on the left. All of these would be blank. Okay? We would just have statements, reasons. So we go to our given. AB is congruent to segment DC. So AB is congruent to segment DC. And if they're not already marked, we would. And then we would write it down, and we would write because it's given. And then segment AD is congruent to segment BC. AD, we'd mark that. BC, we'd mark that as congruent because that was given. So is there anything else we know? Well, we know that segment DB will be congruent to itself because of the reflexive property. So we move into the body of the paragraph or the proof, and we say BD is congruent to BD by the reflexive property. That's enough to say the triangles are congruent, which is what our proof statement was. So we want to write identical what the proof statement was. Triangle ABD is congruent to triangle CDB. Down here, that should be our last statement. And our reason in this case is the side, side, side postulate, because remember, once we knew that these were congruent, then your pencil, you'd want to mark that with 3 tick marks, and you would see side, 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 and side, side, side. It's really just telling the person who's reading it what you were thinking in order to be able to say that they're congruent by side, side, side. Let's take a look at another one. Here we know that angle J is congruent to angle M. That's written right there. And that K is the midpoint of JM. So again, we take the first thing that was written and we say that the reason is given. And we take the second thing that was written and we write it as given. So now, what does that really tell me? Well, when they tell me something is a midpoint, I want to use that idea. So what is a midpoint? Well, mid means middle. So if K is the middle of JM, that means that JK and KM are going to be the same distance because that's what middle or midpoint means. So JK would be congruent to KM because of the definition of midpoint. We also know that both sides of angle K right here are JKN, this side right here, and LKM, this side right here. Those are going to be congruent because vertical angles are congruent. So we write that down. Here those angles are listed because vertical angles are congruent. That's our reason. Once we've written it over here, you probably want to mark it on here. Otherwise, it's real easy to get lost in where you're at. So we'd have tick marks here, and then we'd have a double tick mark on our angle K and another double tick mark on the other side of angle K. And we would be able to see that we would have angle, side, angle, and angle, side, angle. So we would be able to end with our, oops, I didn't change my letters there. That should match these, by angle, side, angle postulate. So let's go ahead and change these to match exactly what it said in the prove statement. And we want to list them in the same order and everything. It should be exactly what the original prove statement said. That should be there in our last statement. These do get a little tricky. I've tried to give you just a couple of questions. The first two are going to be partially filled in, and you'll just need to list some piece of information. But then there are a few for you to work through on your own. So if you get stuck anywhere, just shoot me an email or give me a call. Ask me to give you some assistance in where your train of thinking is. Just remember, you're telling the reader exactly why you believe that postulate is one that you can use for those triangles.